All right. Let me just start by telling you who I am and why I'm doing this, and kind of just a very high-level view of the world that I developed over the past couple of years that I think will help you to understand kind of where I'm coming from. So my name is David Schwartz. I'm the Chief Technology Officer at Ripple. Um, I was the first person that Jed McCaleb, the very first person to work on the current incarnation of Ripple, hired to try to solve the double spend problem with some solution other than proof of work. But I find myself in a very interesting situation now that will help you to understand, like, why is Ripple giving money to research? Why am I having this conference today? It's not because we're kind, wonderful, and generous people. I'd like to think that we are, but the reason that we're doing this is because we have a problem. We have a very fundamental problem in this space. And it's easy to explain by analogy, I think, rather than trying to state it, because it's so weird. Imagine if you were the CEO of Twitter in the year 2000. Now, of course, there was no CEO of Twitter in the year 2000. There was no ecosystem in which Twitter could exist. For Twitter to exist, people have to have phones with internet access, but people are not going to have phones with internet access just for Twitter. You have probably everybody in that room has a phone that they could use to check Twitter out right now. But if Twitter went away, they wouldn't throw their phones away because they were useless, right? They use the phone to access an entire ecosystem. And Twitter could not have built that ecosystem by themselves. Twitter could not have built the phones. They couldn't have built the Wi-Fi access, the fiber, the internet bandwidth. Like, a whole ecosystem grew. And it grew because of all different applications for the very same technologies. And that created the market that's Twitter's potential customer. If you worked in Twitter's marketing department, you wouldn't be thinking, how do we get people to buy phones? How do we get people to get home internet access? You would say, how do we get people who have phones and have home internet access to use Twitter? Like, your market was created because of your competitors and because of an entire ecosystem of services and products that people wanted access to. Twitter could not have developed faster Wi-Fi. Or maybe they could have done that, but could they have also developed, lower power cell phones or brought the cost of the phones? Like, they could not build the whole ecosystem. We desperately need an entire ecosystem. We need new technologies if we're going to revolutionize payments. If we're going to make money move better, if we're going to modernize the financial system, Ripple can't do it all by themselves. And so what we're trying to do is we're trying to foster innovation and commercial development in directions that build the ecosystem that will create the target market that we plan to sell products and services into, but that will also grow an entire ecosystem. And that means that we need our competitors to be successful too. If you think about a cell phone, it doesn't matter to Twitter that you can call your aunt on a cell phone, but if calling your aunt on your cell phone is one of the reasons you carry a cell phone, that makes you a potential Twitter customer. So the competitors are the reason the ecosystem exists. So we need the entire ecosystem to be successful. And that's kind of why we have the Spring Project, which is reaching out to industry and talking to other companies about, do they have good ideas? How can we give them technical assistance? Can we partner with them? What can we do? And we go to researchers and we go to universities and we tell them, hey, we have technical problems that need to be solved. They're interesting. Can you guys please work on them? And if that means, giving people money to get them working on the problems that are interesting and getting them in the space, then we'll do that. And I think the other thing is there's sort of this gravitational field effect. Like, at one time, people really wanted to work at Google because Google was really cool. And for a while, Facebook was kind of where everyone wanted to be and where the action was. And then it kind of moved to like Uber type companies. And then that became not quite so interesting. What we want is we want people to find this space interesting. And we want people who are smart and have the ability to solve the problems that we need solved working in this space. And they're not like the obvious ones are like in cryptography and distributed systems and computer science, but it's a whole world, it's a whole ecosystem, it's a whole world of problems. There are problems in economics, there are problems in governance and sociology, there are problems in politics. This space touches just about everything, and I meet all the time people at universities and other research institutions who are working on things connecting to blockchain in fields that you would, in robotics or just fields that you wouldn't think would connect to it, necessarily directly, because it's a whole new field. And so I want to get people excited and working in that field because, like I said, we have a lot of problems that need to be solved. So I hope you all can see the presentation that I have up. I'm going to talk about two very interesting technologies at first that are connected to the company that I work for, ILP and the XRP ledger, that I hope you'll find exciting. So let me start by just telling you a little bit about the company that I work for. I work for a company called Ripple. I joined in November 2011 before the company actually existed. The company was founded in 2012, so it's kind of funny, like my work anniversary is the company's anniversary. We're currently over 300 employees. We have offices around the world, but our headquarters are in San Francisco. And we're an enterprise blockchain-based solution provider. And we have focused on cross-border payments for two reasons. Number one, it's really like the easiest application of the sort of new blockchain technology. There are certainly other applications, but they're a little bit more of a stretch. They're a little bit more iffy. They're a little bit more speculative. Payments are just really easy. Transfer of value, it's an entry in a ledger. You make the ledger decentralized and distributed. It's a sort of universal payment system. And cross-border, because cross-border payments tend to be where the pain is. That's not to say that there aren't places where domestic payments have problems. It's just in most of the developed world, domestic payments work really well. And to get big institutions on board and to get to where the value is, it's the cross-border payments that are the pain points for them because they're reliant on their competitors to move the money. We have a production network. We call it RippleNet. It's a closed private network. And there are over 200 production contracts and companies that use that network to make and settle payments every day. We sort of think about our long-term vision as the internet of value. And what I mean by that is moving money the way we move information. And I think it's worth taking a step back here to look at how the internet revolutionized just about everything. And while that was an incredible revolution, it was not unprecedented. There was a prior revolution that was quite analogous in shipping and the physical delivery of goods. We had a standardized container for goods, the shipping container, that could go on a truck, it could go on a boat, it could go on a train. And the internet was essentially a standardized shipping container for data. If you think about a UDP datagram, it's a container for data that can travel over Wi-Fi, it can travel over fiber, it can travel over Ethernet. And if you think about like what you need for commerce, you need to be able to move physical goods. Most of commerce is physical goods. You need to be able to exchange information. I have to tell you what goods I have available. You have to tell me you want to buy them. But there has to be a payment too. And that payment is the piece that we've been missing. We haven't had a sort of universal way to move money. And that's kind of like our long-term inspiration as a company to build that internet of value. Now, when we talk to enterprise companies about like this long-term vision of an internet of value, their eyes kind of glaze over. So we kind of phrase our short-term mission, what are we trying to do today, as reducing friction from global payments. That's where the pain points are. Something like 6% of global payments fail today. Something like 30% of them require a follow-up from someone to make sure that they didn't fail. Costs are high. And it's a series of walled gardens that don't interoperate with each other. You know, PayPal and I forget the other one, but the other big one, they're owned by the same company and they don't even interoperate. Like the two biggest US payment systems owned by the same company, they don't even talk to each other. And so you need an account in each system. Like it is a somewhat chaotic mess that still dates back to like batch processing systems from the 70s. So how I think about blockchain is I kind of think about it as analogous to the Ford Model T. Now, we don't all drive Ford Model Ts. We don't. You know, I don't drive a Ford Model T. But if you were kind of a forward-thinking person, when you saw the Ford Model T, you might have said, wow, like this could replace the horse. And the thinking process that you would go through is like, okay, the Ford Model T is expensive and it can't hold a lot of freight and it has maintenance issues and there's no groundbreaking technology in it. It's a combination of, you know, there were some innovations in plastics and rubber. There were some innovations in machining. There were, you know, internal combustion engines got better. But there was no incredible breakthrough technology in the Ford Model T, but it was enough to make people say, wait a minute, like this could be something that could really disrupt horses, because all of the things that we don't like about the Model T, like it can't carry a bunch of cargo, but that's not fundamental to the fact that it uses an internal combustion engine instead of a horse or has a transmission. That's just the technology today. And so if you were sufficiently forward thinking, you could say like, these are the pieces that could really change the way we travel. And I think that we had, and myself specifically, had that same sort of aha moment when I saw Bitcoin. But what has to happen is the design has to mature, right? Like we have trucks, we have tankers, we have sports cars. We don't drive Model Ts. And more importantly, we don't all drive the same car either. So what has to happen is there has to be this maturity to targeting to specific use cases. And that's going to mean that, you know, in the analogy of blockchain, some blockchains may have high throughput, some may have low transaction fees, some may be very decentralized, some might not be. It's like they're going to have different mixes of characteristics that allow them to do what different people are going to want. And one of the things that we looked at is we looked at lots of possible applications for blockchains, things like payments and trade finance and lending. And one of the things that we noticed is that really everything comes down to a payment. If you're going to lend me money, you're going to pay me you're going to give me the money that I borrowed, and I'm going to have to pay you back. If we're doing trade finance, there's going to be a payment. So Ripple kind of went to focus on payments. And we came from, you know, the digital currency space. So let's talk a little bit about digital currencies. They're rooted in blockchains. And what's important about the blockchains that digital currencies live on are these 4 principles. So one of them is that there are no system administrative functions. There's nobody with a privileged position in the system. The system is essentially governed by the code that the participants choose to run. And if I participate in a blockchain, I can run whatever code I want. Nobody can force me to run any particular code or not run any particular code. But if I don't run code that's sufficiently cooperative with that doesn't follow the same rules as other people's code, I can't interoperate. So essentially, the set of people who can interact with Bitcoin or the XRP ledger or Ethereum are the set of people who are running software that is sufficiently compatible in rules that it can interoperate and maintain an agreement. So all state is public. That means anybody can see the network state. All rules are public. That means everybody can tell whether a transaction is valid or not. Everybody can tell what consequences a transaction will have. And all participants can enforce the rules. Because I can see the state, because I can see the rules, I can enforce the rules. And one of the core insights of a blockchain is that the only way to change the state of the system is to demonstrate that the state change complies with the rules. Like in the Bitcoin blockchain, there's no way for one server to say to another, hey, I have a million Bitcoins, don't ask where. Like the only way to convince somebody in the Bitcoin system that you have Bitcoins is to demonstrate that all of the system rules are complied with in a way that leaves you with those Bitcoins. And I think that is the key innovation. This idea that the only way to convince somebody that the system has a particular state is to demonstrate that that state change complies with the system rules. I believe that is like the fundamental breakthrough that we have in blockchains. Myself and a couple of other people in 2011 to 2012 built the XRP ledger, which has a native digital asset called XRP. It doesn't use proof of work. I'll talk more about how the technology works. But I think an important thing to compare is that we built off Bitcoin and we changed the design in ways that made it significantly better for the sort of international payment use case that we were focused on. It takes much, much less time to get certainty around the transaction. The fees are much, much lower. The throughput is higher. The energy consumption is much, much lower. And another important difference is that proof of work is very probabilistic. It's a Poisson process where, for example, in Bitcoin, a block is produced on average every 10 minutes, but we've gone 2 hours without a block, and you can have 2 blocks found at the same time. A consensus is much more predictable. It's a fairly consistent 3 to 5 second cadence. And as a result, that means that for people who just want to move money from one place to another, XRP provides them a much lower cost, and I think also much more predictable cost. Like Bitcoin's costs, I think they're down to around $1 now, but they fluctuate drastically. XRP costs, because the system has such a high capacity, they don't fluctuate as much with use. So if you're just trying to move value from one place to another, what you care about is things like cost and speed. And XRP wins on those metrics. And that's why we think that it is the best digital asset for payments. And that's why also we don't feel like we have to sort of trick people or coerce people into using it. A lot of people say, hey, can you use Ripple's technology without using XRP? Absolutely. We need our competitors to succeed. If XRP is not the best solution for your use case, please don't use it. Don't suffer you know, a suboptimal solution that doesn't do anybody any good, right? This is kind of duplicative. So 40+ million ledgers closed without issue since inception. XRP available on more than 80 exchanges. But I want to talk about the technical stuff because I think that's kind of interesting to this group. So one technical innovation, a core technical innovation in the XRP ledger, in fact, our very first technical innovation was Federated Byzantine agreement. And what that means is that rather than there being some dictator who gets to choose what transactions go in each block, there's an agreement network-wide over which transactions go in a block. And what that allows is that allows the system to better resist what I call soft censorship. If you imagine if the New York Stock Exchange had a dictator who ran it for 10 minutes just selfishly, and then some new dictator ran it for 10 minutes selfishly, that would be a pretty terrible stock exchange. And so long as your transactions are simple and it doesn't really matter exactly how they execute, that's not a problem. But if you want to have more sophisticated transactions like cross-currency payments, where someone might say, I want to deliver 50 euros to someone, and I'm willing to pay up to $60 to do it. Now, a hostile party can sort of resell that liquidity to you at a higher rate. So the fact that you don't have a dictator choosing each block is important. Transactions operate on views, and this is a major innovation that the XRP ledger uses that, combined with invariant checking, provides a higher level of security than I think any other blockchain can provide. And what that means is, let's say you execute some transaction. Let's say you say, hey, I want to send 10 XRP to Jeff. That transaction operates inside the XRP ledger software on a view, which is like a sort of filter through the ledger. So it kind of says, okay, I'm going to retrieve these nodes in the ledger and I'm going to change this balance. And then the view is analyzed for invariant violations. So for example, one invariant is that you can't create XRP. Now, imagine if you said to me, well, how do I know that it's impossible to create XRP? How do I know that this invariant is respected by the software? A terrible answer would be, well, look over the 100,000 lines of code and you'll see there's no place where you can create XRP. Well, that's really hard. For one thing, there's a lot of lines of code. For another thing, there could be some subtle overflow or who knows what. Like, it's hard. And also, the code is changing. So if a new transactor comes out tomorrow, you would have to audit that transactor too. Now, that's not to say we don't do all that. Of course we do all that. The point is the possibility for error is quite high. And as an example, Stellar, which they copied the XRP ledger code, but they added a transactor to merge two accounts. And there was an error in that transactor that allowed it to create new digital currency. And it happens. So when our transactors operate on a view, that view is analyzed for invariant violations. So independent of the code that actually said, okay, we're gonna reduce this, we're gonna increase this, we're gonna change this, there's a completely separate piece of code that analyzes those changes to see if any invariants are violated. Which means there's like literally a line of code that I can point to that says, if this transaction somehow created XRP, throw its results away. And it replaces them with a little note in the ledger that says, this transaction violated invariance. Someone please go find the bug and fix it. Now, fortunately, that's never happened, but that is a pretty major, I think that's one of the major technical innovations that we've made that provide a higher level of assurance that the ledger state won't be corrupted. So I want to talk a little bit about why consensus is robust, because I think for a while people sort of thought that proof of work was the secret sauce in blockchain because Bitcoin came out first and proof of work was like the most visibly obvious innovation. But I think the innovation is more around what I was talking about before. Ledger state is public, transaction validity rules are public, transaction execution rules are public. All that leaves is the double spend problem, right? If I have one Bitcoin, I can send it to Alice or I can send it to Bob. Well, what if I try to do both? Well, all you need to solve the double spend problem is an agreed global transaction ordering. If we agree that my transaction to send the Bitcoin to Alice comes before the transaction to send it to Bob, then we can all agree that the second one is unfunded. So really all you need is a global transaction ordering. And that's pretty easy because you can sort transactions. All you have to do is sort, every transaction can be represented as a number. You can order them simply by sorting them in any agreed way. The only problem with that is sorting them would work if every transaction that would ever exist is sorted before any single transaction is confirmed, which of course is not a practical system. So what you need to do is you need to agree on groups of transactions to sort and execute as a unit. And so the way XRP Ledger consensus works is by agreeing on groups of transactions to sort and process as a unit. And it's remarkably robust. When I first started working on this problem, it seemed almost intractable. It seemed incredibly complicated. But as we peeled the layers of the problem away, we noticed these three principles that are extremely important. So one of them is if a transaction is absolutely perfect, if it's a valid transaction, it's properly signed, there's no double spend, it was submitted on time, nobody saw it after the consensus process started, every honest node will say, yes, that transaction should go in the ledger. And if a transaction has any reason not to be included, it's not properly signed, it's a double spend, it was submitted a little bit late in the round, it's perfectly okay not to include it. There's no harm by not including a transaction that's not perfect. If you're an honest participant and you really want your transaction to go through, you can easily make it perfect. Submit it on time. Don't make it a double spend. Properly sign it. Include an adequate fee. It is not difficult for a participant who wants a transaction to go through to make that transaction perfect. And if the transaction isn't perfect, well, sorry, your transaction might not get included. You want it included? Make it perfect. Your problem. And this is the important point, which is that valid transactions that don't get into the consensus set, if they're still valid, they'll be voted into the next set by all honest participants. So why is that? The criteria for an honest participant to vote yes on a transaction is very simple. The transaction is valid, and we saw it before the consensus round started, and it pays a sufficient fee. Now, if we rejected a transaction in round 7, everybody who rejected the transaction in round 7 necessarily saw it before round 8 started, right? You can't reject the transaction and say, hey, we don't have consensus on this, and then have not seen it. So this is why consensus works and is robust. The honest participants do not have difficulty agreeing to it. Essentially, all you have to do is defer a transaction to the next round if somebody says they saw it late. And every honest participant values agreement over everything but correctness. So obviously, no honest participant is ever going to, allow an invalid transaction in. And even if they, even if they did, no one else is going to agree with them. Obviously, correctness is priority 1. Anything that's not correct by system rules is just right out. It's as if you didn't say anything at all. But second priority over correctness is agreement. The system is useless if there isn't agreement, even if it's correct. It's more useless if it's incorrect, right? Like if transactions just move funds without proper approval and by no rules. But we also need agreement, because otherwise it's not a useful payment system. And by the way, the third priority is performance. You can have agreement and correctness by never executing any transactions at all. That's not a very useful system. So validations act as a safety to confirm we had agreement. So you have the Byzantine generals problem. You can't necessarily know that you have agreement, but you can know that you had agreement. At some point later, you can discover that a supermajority of people agreed at some point in the past. And that's how the system makes forward progress. So there's one process called consensus that's attempting to reach agreement. And then there's a second process called validation that's monitoring the consensus process to determine that at some point in the past, we definitely had agreement, and therefore we can rely on those results. And that's kind of how you solve the Byzantine generals problem. You may not be able to guarantee that the two generals attack at the same time, but if you got slaughtered, you know it. And if you didn't get slaughtered, you know it. You find out later on, like whether you won the battle or not. And then when you won the battle, then you know. Network splits can be detected as they happen because the consensus process is an active process with the active messages. So you can tell when you're not talking to someone or not hearing someone, and when they might be potentially like trying to agree on some other ledger. This makes consensus a little bit fragile. In this respect, I would say consensus is less robust than proof of work, but I have a counter to the robustness principle, which is this. If reliable operation is not possible, unreliable operation is not a good thing. So if you have a network split, proof of work can allow you to make progress on both sides of the split. That's a bad thing, because one side or the other is going to eventually be invalidated. And validation performance can be trivially monitored because validations are signed, and treachery can be proven. So if someone says, hey, you said no on this transaction in round 7, but then you said no in round 8, like you saw it, treachery is provable. And what we expect will happen is that if validators are treacherous, people will simply stop listening to them. Whereas if validators are reliable, people will keep listening to them. So over time, you should get sort of a collection of nodes who only seem interested in forward progress in the system. And we do see that in the real world, although analyzing sort of the robustness against different types of attacks is an interesting problem. And that's, there's been a lot of analysis of proof of work's robustness against different types of attacks. There's been less analysis of this sort of federated Byzantine agreement algorithms resistance to attacks, and that's certainly an interesting thing to do. The XRP ledger is not UTXO based. We don't use unconfirmed transaction outputs. Accounts are primary objects on the ledger. And that gives you some features that you can't have in a UTXO system. Key rotation, you can change the keys that need to sign your transactions without changing your receiving address. Managed multi-signs, you can have a multi-signature, like these two people have to sign my transaction and they can rotate their credentials. And you can select what assets you want to accept as payment. The XRP ledger is a multi-currency ledger. We have some pretty sophisticated features. I won't go into too much detail, but we have something called issued assets, which allow accounts to issue assets, and community credit, which allow accounts to sort of owe each other funds and allow debt settlement to be used as payment. This is why we're called Ripple. Ryan Fugger in 2004 built the first system called Ripple Pay. He couldn't build a decentralized digital asset because he didn't have the technology to do it. But he had this idea, what if you had thousands of centralized assets? What if, like, Jeff does Bob a favor, and so Bob owes Jeff one, and that's an asset. It's a centralized asset, but it's an asset that's not there are enough of them that they behave in a decentralized way. And then if you have pathfinding and liquidity between them, you get a decentralized payment system because everybody can sort of choose the centralized asset that works best for them. And those Let's type features, lending, kind of a little bit like Koala, are still implemented on the XRP ledger. And they're quite fascinating, and I hope someday that they kind of catch on, because I really think that that's an incredibly interesting area, but they've not been that popular. There's an integrated decentralized exchange. You can place offers to trade assets. Payments can take those offers. And we have pathfinding and multi-path payments. And why that's important, there might be an offer to exchange one asset for another at a really good rate, but your payment may be bigger than that offer. And so you want to go through multiple paths to grab the lowest cost liquidity. So all that stuff on digital currencies, can they solve the payments problem? Well, what's wrong with payments today is that the networks are disconnected. Banks don't talk to remittance companies. Mobile money doesn't talk to banks. Everything is just completely fragmented. And as a result, global payments are very slow. They take 3 to 5 days. They're very costly. There's trillions of dollars trapped in bank accounts that people deploy in order to make payments. So if I can't make a payment into Thailand quickly, but I need to pay a vendor in Thailand, I'll put Thai baht in a Thai bank account, just sitting there waiting for me to need to make a payment. This nostro-vostro relationship is trapping trillions of dollars of liquidity by companies that have high costs of capital. And it's unreliable. This is why companies like Amazon, Airbnb, Uber, they all have hundreds of people who run their payment department. Payment companies would love to go to Amazon and say, fire all your payments people, we'll do your payments for you. But there isn't anybody who can do that today because the global payment system is so fragmented. What companies, like new corporates, want are on-demand real-time payments at low cost, and they want a clean, modern experience with tracking end-to-end. And nobody can give them that. And we thought we would solve that problem with blockchains. Like, I know when I first started working on Bitcoin, I was like, hey, cool, this will solve the problem. Unfortunately, we've recreated like a newer, sexier version of the same problem. We have 1,500 digital assets on blockchains that don't talk to each other. So we didn't solve the interoperability problem that we thought we were going to solve. But also, the vast majority of today's value are in non-digital currency systems. So if we had an interoperability solution that interoperated the 1,500 blockchains that represent 0.01% of the world's value, that would be a rather inefficient effort. What we need is an internet of value that connects all systems of value. We need full interconnectivity. This is Ripple's long-term vision. And that's why two people who work at our company, Stephen Thomas and Evan Schwartz, no relation, came up with Interledger, which I think is probably one of the most exciting innovations. It's a light, clean, simple protocol for connecting value systems. It's an open protocol. It's not biased. It doesn't preference any technology over any other. It's very much like UDP. It's built around a community group at the W3C, the Web Standards Company, and it has over 275 companies that are working on it. And it's a really good parallel to the internet architecture. So if you know the internet architecture, we have this IP thing that is like the glue. And then we have and TCP and UDP are like the next layer that allow us to move, very primitive movement of data. But we have innovation below it. You can put IP on top of Wi-Fi. You can put IP on top of fiber. You can put IP on top of Ethernet. And we have innovation above it. You can put HTTP on top of IP. You can put SMTP, email on top of IP. The IP piece and the TCP UDP pieces have stayed the same. Meanwhile, we've had innovation on both sides. We've had revolutions on both sides. The internet wasn't originally even used for the World Wide Web, right? And it wasn't originally used over Wi-Fi, but we could slot those pieces out and keep IP the same. And this is what we've designed for Interledger. There's a protocol called ILP, which is it's just a packet that holds some value. And just like a router can switch a data packet from one network to another, a connector can switch an ILP packet from one ledger to another. And below it, you can have banks, you can have blockchains, you can have Lightning, you can have you can have blockchain accelerators like Lightning below it. And above it, we have a collection of protocols that handle payments over different protocols. And I think it's the same sort of dumb middle idea. In the early days before the internet, the middle was smart. If you imagine if you had made a phone call, there would be a circuit that was reserved for you. And we switched to a packet switching system where the middle is dumb. It's just the best effort to move a packet, and all of the intelligence is at the ends. And that's what's permitted this innovation. That's what's permitted two different people to use the same internet to exchange completely different types of information over vastly different protocols. It's because the middle doesn't care. And that's the principle that the Interledger brings. It's a dumb middle. ILP is a perfect platform for micropayments. Over 1 billion ILP payments were made in 2018. The average payment was something like 1/1000th of a penny or even less than that. And payments can stream. So this is the most important thing I think that I can say. I think micropayments are just going to take over the world, because micropayments, you can do anything with great micropayments, and all of the complexity of payments go away. So what is the complexity of payments? I want to deliver 100 euros to someone. Do I get a quote? How do I know who to trust? And if I get a quote, do I pay for the quote or do I get a free quote? If I get a free quote, they have to give me a pretty crappy quote, because what if the exchange rate moves against them? What if I'm only going to take the quote if the exchange rate moves against them? Now, maybe they'll say, look, we'll give you this quote as a free guarantee, but you'll probably get a much better rate. Like, we're not trying to screw you. We just need to protect against the fact that you might only take us up on this if the exchange rate moves against us. But what if I have 3 quotes like that? How do I know which one to take? All of the complexity of trust and free option problem and all of that goes away with micropayments. So imagine if I want to deliver that 100 euros and I have 3 paths I could take. I have 3 connectors. I don't trust any of them. I can send 1/1000th of a penny to each of those 3 connectors and see which one delivers more euros to my destination. And the one that delivers more euros to my destination, I can send money down that path faster. And I'll keep sending money down the other paths, because maybe the liquidity will change. Maybe liquidity will run out. Maybe one of those connectors itself is trying multiple connectors and trying to find the best rate for me iteratively. You can make any payment with great micropayments, and all of the complexity of the middle goes away. The middle can be dumb, the middle can be untrusted, all of the smarts can be at the beginning. Let's say I'm getting a really good rate, I can speed the payment up. Let's say I'm getting a terrible rate, the liquidity is not good, I can slow the payment down, maybe even stop it and try again a little bit later. I can balance. Am I in a hurry? Do I need a great rate? Or like, all of the intelligence can go in the ends, and the middle can be dumb and untrusted and making a best effort, just like the internet. And I have to say, it's shocking, but it really, really works for payments. So summing up my own personal view, and I think to some extent my company's view, interledger payments plus digital assets can build the internet of value, can get to that world where we can move value as easily as we move information. I'm going to stop sharing because that's the end of my presentation, and I have a couple more things I want to talk about before I go into questions. So one thing, I want to talk about a little bit about what we need in the blockchain space. Decentralized governance, like, how do you govern a system that nobody has a legal right to run? How do you govern a system whose governance is just the code that people choose to run and who can interoperate? Do you have institutions? Do you have leaders? Do you hold elections? Do you, like, what works? What gets stability? We have no idea. We don't know. At least I don't. Another technical problem we have is quantum resistant cryptography. There's going to be quantum resistant cryptography independent of blockchain. Everybody's working on it, but we have a very special problem in blockchain. For example, it's critical to us that the public keys be compact. Verification time is critical to us. There's all kinds, so we have sort of unique requirements that we would like to see out of quantum resistant algorithms, and we don't want, like, the world to build only quantum resistant algorithms that work terribly for blockchains. We'll use them if we have to, but if we build an algorithm into a blockchain, it's there forever. So if it's very slow or very bulky or has other, downsides that that hurt us in the blockchain space, we would like to have really good quantum resistant algorithms, preferably ones that behave just like, ECDSA or ED cryptography, that behave like the algorithms we're using today, but were quantum resistant. That would be lovely. And we have no idea what the path is to get to that, obviously. We don't know what area of cryptography that's going to come out of, or whether it's going to be some entirely new category. So we need that. Also, there have been tremendous innovations recently in the zero knowledge proof space. I don't know how many of you know how amazing, I'll make a little bit of a technical detour just because this is pretty mind-blowing to me. So you can make a circuit out of AND gates and OR gates that replicates almost any sort of algorithmic proof that you can write on a piece of paper. So for example, if you want to prove if you want to prove that you know something that hashes to a particular result, you can make a circuit that lights up a light if you have that correct input. Or if you want to prove that pretty much almost anything can be expressed as sort of a circuit. Like, let's say I'm transferring a vaccine to you, and I want to prove that I got that vaccine through a chain of suppliers that are registered on some system. I didn't, find it on a loading dock, but I don't want to tell you who those suppliers are. We could make an electronic circuit that would light up a light if I submitted in the proper proof. And if I don't tell you what I fed into that circuit, then you won't know who the path was. You just know that it meets those rules. We can actually build zero knowledge algorithms for any circuit, even one with millions of gates. And so essentially I can submit a proof to you that I know the inputs to make that circuit like output a particular output without revealing what those inputs are. That's something that was not possible 4 years ago. I mean, that's a massive new cryptographic primitive that's tremendously powerful. So, and the example that I gave of like tracking a vaccine. So pharmaceutical companies don't want their competitors to know what their distribution flows look like. But it would be nice if I could prove to someone I gave a vaccine to that I didn't find the vaccine on the back of a truck, or I didn't sell the same vaccine to 2 different people. Like, we can build public data systems in which I can provide proof to you that certain things happened or didn't happen without revealing the information that makes that proof correct. It's groundbreaking, and we need more. We need more. On the business side, I think the focus for us is on things that have direct practical utility. That's kind of why we're focused on settling international payments. I don't think cryptocurrencies are ready for mass retail adoption yet. You guys are probably all too young to remember this, but there was a time when the internet was all text. There was a time when if you could find an internet service provider in your area, they would mail you a physical piece of paper to tell you how to edit your DOS batch file settings to load TCP/IP drivers. That was not when Twitter should exist, right? That was not when Facebook should exist. Like, we're kind of in that stage where we're missing those pieces, and so we need to build those pieces so that we're ready. But I hope I'm wrong on this. Like, I hope somebody comes up with some mass retail adoption of cryptocurrency tomorrow and it takes over the world. But I don't think that's realistic. I think we have a long way to go building the infrastructure. On the sort of financial institution side, I've been quite surprised recently, probably in the last 2 years, that banks and non-bank financial institutions like payment companies and remittance companies, they're really receptive to these new technologies for reasons that I think are quite surprising. So one reason on sort of the bank side, banks used to say, we don't care if we lose the payment business. We're not payment companies. We don't make a lot of money on payments. Like, if people go elsewhere for the payments, what do we care? Like, it's a hassle for us. We have to verify, we have to do compliance checks on the recipient. We have to deal with other banks, and it's a mess. Like, well, we would be perfectly happy if people use their phones for their payments, or if people use, companies like TransferWise. They realize that that strategy has horrifically backfired on them for one reason. I'm going to keep my money where I can make payments. Why do I keep my money somewhere? Why do I have money? Like, so I can make payments. So if I don't go to the bank to make payments, why would I let my bank hold my money? Why wouldn't I just keep my money where I make my payments? And that's what's happening in the rest of the world. Like, the rest of the world is skipping landlines, like the third world is, they're going right to mobile phones. They're going to skip banks. And if I don't go to a bank to hold my money, why would I go to a bank when I need a loan? Why would I come in as a complete stranger off the street and walk into a bank and say, hey, I want to borrow money from you, when I have relationships with with payment companies? So banks are realizing that they can't just, the very largest banks, if you're Deutsche Bank, HSBC, Credit Suisse, like, whatever, Citi, JP Morgan Chase, yeah, you're fine. But there's thousands of banks, right? Like the number of banks that are fat, dumb, and happy in that way, maybe 20, 30, 40, less than 100 of the thousands of banks and financial institutions. And they're getting squeezed. On one side, they're losing the payments business to non-bank payment companies. And on the other side, they're getting squeezed by their correspondents that want to make more money. And for the first time in history, we're seeing banks reducing their number of correspondent relationships because they're expensive. But that's dangerous. If I have 10 correspondent relationships and one of them gives me a hard time, I'm like, hey, then you're not getting my business. But if I only have 2, it becomes a lot harder for me to push back. And the payment companies, the non-bank financial institutions, they kind of don't like being dependent on banks who they see as competitors to move money. So non-bank, like, if you think about a non-bank payment company, think about Apple Pay. But how do I get my money into and out of Apple Pay? Like that's coming from companies that are typical like banking institutions. And so they're if you're Apple Pay, you probably have enough leverage that you're not worried about a bank pressing. But what if you're a much smaller company that only has, 1 or 2 banking relationships, and those are you're critically dependent on those. So they're very receptive to new technologies that get them out of these problems. And one of the things that we're seeing just in the past year is even those very largest banks are starting to think like if the banks that rely on us start to find other ways of moving money and other ways of settling payments, what's the business for us like in this new world? How do we continue to hold the position that we have? And so they're starting to look, and at first it was kind of just more like they were looking at the technology to say that they didn't see anything in it to kind of assuage their investors and their business their business allies. But now they're starting to look at it much more seriously to say, wait a minute, like if the world is going to change, how do we remain relevant? And they can remain relevant. They have things that don't go away. Like I'll give you an example. Like you look at a company like Western Union, and Western Union might say, oh, well, we're going to be disrupted by these blockchain systems. People will use other currencies, or they'll mix and match. They won't all go through a network like we have. But if you think about it, like Western Union has thousands of places where cash can go across the counter. Like that is not. This is going to be a long time before that becomes irrelevant. And if that's part of a network that has other cash in and cash out points and other liquidity providers, that just increases the value of those cash in and cash out points. Let me see what else. Scalability is another huge area of research in blockchains. That's the one thing. You remember I was talking about the Model T and how like it seemed like people would say, well, it needs a lot of maintenance, but maybe we could solve that. It doesn't have a lot of cargo capacity, but we can increase that. The one thing that blockchains have as a limitation that it's not clear how we're going to solve it is the scalability limit. So I think anything on that front, we have lots of possible scalability solutions, things like side chains and things like use of slashing, where you provide maybe a zero knowledge proof that something happened on a side chain, but none of those are the one slam dunk solution. So that's kind of an interesting area of work. I will say my other crazy thing, my crazy thing about micropayments eating the world. I'll give you another crazy thing about blockchains eating the world. Now, I could be totally wrong on this, just like I could be wrong about micropayments, but it's a food for thought. One of the big advantages of blockchains is there's no centralized system that you have to protect. And I would also point out that no major blockchain has had any downtime in the past 3 years. Like what centralized system can say that? And centralized databases are expensive. They're not, the argument that they're like a cheap and solve problem, they're not. Like a large centralized database can cost millions of dollars a year just to operate. And a significant fraction of the operational cost is around keeping the data secure. You have a centralized database, and if bogus data gets into it, that's a huge problem. And so operationally, who has access to that data? How do we check it? How do we protect it? All of those problems go away with a blockchain-based design, where you have to prove that state changes comply with system rules to make state changes. So it's possible, particularly if we can make some progress on the scalability problem, because that's the downside that we don't really have a good solution to. It's possible that blockchain designs could kind of eat the world, and they could become the preferred way to develop online transaction processing systems, at least where scalability isn't a major issue. They are cheaper, they are more reliable. We don't have good tooling. So anyone who wants to develop software tools, like we don't have good tools. So we have a historical accident. The first application for blockchains was cryptocurrencies, digital assets. Like that was the slam dunk application. So in theory, what should have happened is someone should have built a generic sort of blockchain tool or library or design. And then cryptocurrencies like Bitcoin and Ether should have been an application built on top of that generic tool set. That's not what happened, because the first use cases were digital assets. What we got was a digital asset system that uses a blockchain. And then when people had this idea that, hey, like if, the Ethereum project, like we can use a blockchain as sort of a world computer, rather than going back and building a design that looks like a sort of blockchain from the beginning, they took a sort of digital asset system and they layered computing on top of it, which unfortunately is still, it's not a rational design. The rational design should be digital assets are blockchain applications. They should be one thing that we should build on top of a generic blockchain sort of toolkit. We're not quite there yet. So if we're going to use blockchains for all kinds of different things, for the provenance of vaccines, if we're going to use them to track authenticity, if we're going to use them for trade finance, if we're going to use them for all these other things, we need toolkits around building good blockchains, not based on sort of digital assets. So I think we kind of need to do a software work from scratch. Thank you so much. Thanks to Berkeley, and thanks to all of you for coming. I hope I got you interested. If you weren't already, I assume most of you probably already were, but you have a better idea of what kind of research we need and what we're doing. I hope I inspired you to take a closer look at the XRP ledger and maybe some of its crazier features, like the multiple asset features, pathfinding, payment, lending, those kinds of things. And I hope you take a look at Interledger, because there really is a sort of beautiful simplicity to it. And for those of you who are in fields that are not directly, that don't seem directly related, but it doesn't matter what they are, like, you know, economics, governance, sociology, like there's all of those things connect to blockchain in some way too. So we need all of it. Like so little of this technology has been studied yet. So this is an opportunity to get into an area of research that's, you know, that's in its very early days and where that is desperately needed.
Well, so thank you very much, David.
It was a pleasure.